So now these problems say unlike radicals. So the ones where they were like radicals, I also want to point out that everything was already as simplified as possible. So you saw something like the square root of 5, but you would not have seen something like the square root of 25 where you could, oh I'm sorry, I should use a different number. You wouldn't see something like the square root of 50 where you could pull 25 out and turn it into 5 square root of 2. So that would kind of be unfinished if we had problems like that. So here we have like something like 20 where I can probably break it down, 45 where I can probably break it down, and the same deal with 180. So we're going to simplify these. And right from the start, I don't see anything that I can combine, but let's just rewrite the problem anyway. 2 square root of 20 plus 3 square root 45 plus the square root of 180. And now we're going to not worry about putting anything together yet. We're just going to worry about simplifying these like problems that we did in 2.1. Now I'm going to try to color code this a little bit. So I will trace the square root of 20 to make that stand out, the square root of 45 to make that stand out, and the square root of 180 to make that stand out, so that you can tell apart this 2 from the next thing I write. So that 2 matches up there, and now the square root of 20 becomes 4 times 5 on the inside, so I'm going to pull the 4 out as 2 square root of 5. And just like before, if you are unpracticed with these, but having done practice in 2, you probably should be okay. You could rewrite this all out in steps, and that makes it way clearer. Moving on to the next part, I have plus 3. Now I see the square root of 45, and I'm thinking of 9 times 5, and when I pull that 9 out, it becomes 3 radical 5. Moving on. Now I'm thinking maybe 180, I'm thinking of like 9 times 20, but I think I can do better than that. I think I can do a higher perfect square. So if I use my resource, I can think of 36, or maybe in my head I was actually thinking of this as 4 and 5, and then 4 is a perfect square, 9 is a perfect square. So when I multiply 4 times 9, I get 36. So I'm seeing 180 as 36 times 5, and when I pull out 36, it becomes it becomes 6 square root of 5. Now that's larger numbers, so maybe in my head I'm checking that one out, and I'm thinking that if I were to sneak that back in there, it would be 36 times 5, and I'd get 180 that I started with. Looking at this, I could try to start putting all these 5s together, but instead I'm going to rewrite 2 times 2 is 4 square root of 5, 3 times 3 is 9 square roots of 5, and then 6 I just rewrite. These are all addition symbols, so because of that I'm just going to be like, well, 4 and 6 gives me 10, and 9 is 19 square root of 5. And maybe you did it this way, 4 plus 9 is 13, plus 6 is 19. Problem 2. Rewrite 4 times the square root of 54 plus 2 square root of 24 minus the square root of 150. Let me make this 5 more clear. And I'll do the same deal with the color coding again. I'm sorry that I paused the video and didn't catch where I was at. So you might be hearing me say the same thing again. These are your clues, right? So you see 6 and 6. So you're going to predict maybe that a 6 ends up here. So why not just take 150 and divide it by 6 in your calculator? And if you do that, did I get that correct? 2 times 6 is 12. You're left with 30. Yeah. So I got 25 times 6. So when I pull 25 out, it becomes 5 square root of 6. Next step is to rewrite this. 12 radical 6 plus 4 square root of 6 minus 5 square root of 6, giving you 16 square root of 6 minus 5 square root of 6, and then 16 minus 5 becomes 11 square roots of 6. Same as before. If you were on a test, you could redo this if you wanted. You could multiply things back out, but definitely get a calculator, get a decimal approximation on this, and then see if it ends up being the same down there. And if you're at home, you could even use Wolfram Alpha to type things in. 3 will be an OYO problem, so I'm going to put the answer up to that in just 5, 4, 3, 2, 1. So unless I made a mistake, I got negative 16 square root of 3 plus 10 square root of 6, and you also might see that written 10 square root of 6 minus 16 square root of 3. So that would be done. You can't put these together. They are both in their most simplified form, and you can't pull out any perfect squares.